Welcome everyone to this new day of our day 103 of our GFG POTD streak. And if you're new to this channel, please like, share, and subscribe so that we can learn, grow, and maintain our streak together. So let's see to the question what the today's question is about. It's a medium category question with the points for, and let's see what it's saying. What it is saying. There is a row of n houses. Each house can be painted with one of the three colors, that is R, G, or B, that is red, green, or blue. The cost of painting each house with a certain color is different. Okay, you have to paint all the houses such that no two adjacent houses have the same color. ये question तो sorry, this question seems uh, like a very standard one, but let's see. Continue reading the question. So find the minimum cost to paint all houses. The cost of painting each house is red, blue, or green is given in the array R, G, and B respectively. Okay, so these are the colors you can take for coloring the houses, I guess. So for n equals to 3, the output is 4, and they are saying that we can color the houses in the RGR manner, right? And the minimum to incur minimum cost, we could have obtained a cost of 3 if we colored all houses red, but we could not color adjacent houses with the same color. Okay, they are saying that if I would have painted all three houses using this R array only, R array itself, then it would have 1 plus 1 plus 1, 3. But since you cannot, two adjacent houses cannot be having the same color, and as you can see that the minimum cost to paint a house is given by the R red color, right? So that's why they chosen two houses, like the first one and third one from the R array, and this the second one to the second minimum cost that is given by G array. But I have a doubt. Maybe in this case, all the values were same. So can they be okay? So there are like now multiple values which are not same. Like in the same R array, you have three different integers. Okay, okay. So 5 into 10 power 4 is the time complexity. So that let's discuss about the constraint. So 5 into 10 power 4 is the max complexity. That means you can worst go to n square, right? Because that will be less than equals to 10 power 8. So if you do not understand this 10 power 8 logic, I always emphasize on this point because it is very important. You must see that time complexity video, that how to trick the TLE. It must be splashing up here now. You can watch it and then continue this video. Okay, so let's continue again. So let's copy this second test case because the first test case is a very generic one. If we are able to derive something from the second test case, maybe we could use that intuition in a solution. So let's say if n was equals to 3 and r was nothing but given as the first one, that 2, 1, and 3, right? Or we can assume that the r was having just one color, g was having just one color of 3, and b was having just one color of 4. Then we can directly say that choose the minimum value, and among these three, that is 1, and that will be our answer. But let's divide the question, like let's now make the question bigger for n equals to 2. So the R will have the color as what? What it should have? Let me think. Let me think. So suppose what the R is given as, let's say we have n equals to 2, then R would have just two values. So let's say 2 comma 1. G will have two values. So that is, let's say 3 comma 2. I'm taking the values from the above test cases, and from B, let's say 1 comma 3, right? And I need to paint two houses, right? So what I need to do, I should take the minimum of this. What is 1? That means I should first paint my first house with B, and second I should take the second, since uh, we cannot have the adjacent as the same color. So for the next thing, B will be out of the scope, and we just have to compare with these two, right? So it will be 1, right? 1. So total cost will be 2 for n equals to 2. But let's say for n equals to 3, what are we doing here is 2, 1, and 3, and 3, 2, and 1, and 1, 3, and 2. So we need to consider all the possibilities, right? Before finding the minimum. So mm, what I can do is I can make an array first as that's a 2D array for the comparison. Let's say for I make this array of n is to 3, and I have this array now, and it will be easy to make the comparison now. So 0, 1, and 2, 0, 1, and 2, right? So this is nothing but it is representing n, right? And this is representing that if n is n was equals to 1, if n1 is equal to 2, and if it is n was equals to 3, right? And this row is representing the first thing, this thing. It is representing this thing. The second column will be comparing the values of from here, right? So let us see. So we need to, so this is the R column, this is the G column, and this is the B column. So we need to include, since n is equals to 1, then just we need to include all the available values, that is 2. That is 2. The first value of R, the first value of G, and the first value of B, that is 2, 3, and 1. And let's suppose for n equals to 1, it was just this case. है ना? So for n equals to 1, it was just this case. For 1 equals to 3. That means the R array would have been just like this, right? And what I need to return in the answer, that the minimum of these three, right? So that means after processing for all these cells, I need to return minimum of the last cell. So let me write it first of all. So that is the intuition, first intuition, right? I just derive it from considering the base case if n was equals to 1, right? So let's now start the comparison. So there are three possibilities, right? Either I can start my coloring of the house. The first color of my house should be either be red, green, or blue. So let's assume that I have started from red. So what's the value of red here? What's the value of red here? The value of red is 1. In the second column, the first value, that is 1, right? But I need to, and at this point, at the second cell, at this point, I need two houses, right? To color two houses. So I need to take one more value, right? And what will be the feasible one? To take the minimum of the remaining colors, right? Because no two adjacent colors are allowed. And where are those minimum colors are residing? It is residing here, is residing here for this cell, because this cell for was is for R, this is for G, and this is for B. We assume it that when we put the values 2, 3, 1. So that means for the second cell, second row, first cell, I would take the first, assuming that I am starting from the red, and will take the minimum of the from the above, because above was the combination of colors we have for n equals to 1, right? So what's the minimum then? 3 comma 1. If the minimum is 1, right? So it will be updated as 2, right? So it will be updated as 2. Let me write it again, 2. So, but this another possibility is that we can start from green. So what's the value of green here? The value of green here is 2, right? So I will take 2, plus I need to color one more house, right? I have to take different colors, and different colors will come from R as well as B, because G is already considered. So what's the minimum? Because I need to minimize my cost. So among 2 and 1, the minimum is 1. So 2 plus 1 will be equals to 3, right? Similarly, for the third possibility and the last possibility, that is we start from the blue color. So if we start from the blue color, then what is the cost for the coloring it? The cost is 3 as of now, as mentioned in the array. So I will take 3, plus I need to consider one more house. So I will take the minimum of the rest of the remaining colors that will come from the adjacent two cells, right? The remaining two cells, or we can say the minimum will be 3 plus 2, that is 5. And for n equals to 2, I can say this column, this row is returning minimum as 2, right? So I can say that if n equals to 2, the data was given this one, that R as 2, 1, 2, 2, 1, 3, 2, and 1, 3, then the answer would have been 2, right? And we have verified that thing also using the manual dry run, as you can see here, right? So that is verified. So now for n equals to 3, what we have to do? We need to utilize the sub problems, the sub answers we make. We already know what is the minimum value for 2. Now let's just consider the minimum, find the minimum value for 3. The same way we found it for the second row. So what I will do, there were three possibilities, right? So I will just again start from the first cell, and I will take the red as my first house color, so that is pointing as 1, right? So I will say 1 plus the minimum of the remaining, that is G and B. The and minimum and the number of houses I need to paint is 2, right? And these are all the colors, these are all the answers that's saying that what's the minimum cost you need. So if I take this combination, R as first and G and rest of the colors, remaining colors, to color my houses, so that will be minimum of 3 comma 5. So it will be 1 plus 3, that is 4. It is coming from this box and this box, right? Similarly, the second one, I will fill it just for you. So it will be 3 as it is mentioned. One sec. I did a mistake. I did a mistake. Hmm. The R column is here, right? The R column is here. So the third value is 3. So I need to start with 3 plus the what? Let me see. I hope we are right till this point. Okay, so I took the first color of R and I'll take the possibility from G and V and the minimum possibility. So among 3 and 5, the minimum is 3, so that it will be equals to 6, right? Okay, now takes the G. So G, the third value of G is 1, so I will take 1 and I will consider the minimum of the rest of the adjacent values, that is 2 and 5. So that gives us 3, right? Again for blue, the last value of the blue is 2, as you can see in this array, and the minimum for the rest of the thing is it is 2 and 3 from the R and G it's coming, right? So it will be 2 plus 2, that is 4. And since we are at this third row, that means this is the answer for n equals to 3, right? So return the minimum of these three cells. What is the minimum here? 6, 3 and 4. The 3 is the answer, right? And you can dry run it also. Just add one more column here as we did, so it will be 3, 1 and 2, right? And as you can see, we have three houses, right? So we can take three different colors and took the minimum. So as you can see, this will be 1 here, right? This will be 1 here and this will be 1 here. So these three ones are adding, summing up and giving the answer as 3. So that is it. So this dry run which I just showcased you, I need to code it. So what will be my first steps? So let's decide the steps. So this is my first step, that I need to make a DP array of n cross 3, right? Step 2 will be, what? That fill the first column with the exact values of the, fill the first row of the DP with the exact values of the first column, right? So it will be fill first row of DP with values of RGB first column, right? This will be a second step. Step 3 will be, while I was comparing, write some code for that comparison. So where I was starting from, from 1. So I will say that for I equals to 1, I less than n, right? I plus plus. What I was doing, that I was at this point, right? DP of I and 0, right? I was at this point, I was comparing just three cells for any number of n, right? So I will just say the dp of I and 1, the dp of I and 2. So these are the only cells that I'm comparing, because we have only three colors. Okay, so can I write any pseudocode for this? So let me figure it out. Just wait a sec. Great. So when I was this row, I was using the previous row, right? So I will say, first I was using the same value, the from the RGB color. So I will say, so this was the first row was for R and for G and then B. So I will take the value from R, that is R of I, plus I took the minimum of the remaining one, and the remaining was coming from the above row. So for the above row, we will do dp of I minus 1, dp of I minus 1, right? And this is what with the value of the column. So it was 0, right? And I was comparing with the rest of the columns, that was 1 and 2, right? So this is right. Similarly for this thing, we will write for g of I plus the minimum of, nothing will change, just it was 1, right? We are updating 1, and we were comparing, similarly we were comparing 0 and 2 in the above cases, because we were filling the first cell. Now since we are filling the second cell, then I need to compare it with the first cell and the third cell, right? And if we are filling this the third cell, then I need to compare with the remaining cells, that is first and second, right? And here, and at this one, the first line I was comparing, I was filling the first cell, so I need to compare with the rest of it, right? So it should be 1, right? It should be 1. 1 2 0 2 and 0 1. Yeah, that's it. So this is our pseudo code. So now let's try and run this code. So let's start from the step 1. that making a DP array of n cross 3. So let's make it. So since the long is given here, so I will say long DP. I will specify the size that new long n star 3, right? Why? Because there was only three colors, right? Why? Because given three colors. Step 2, I need to fill the, let me write it for you. Fill first row of DP with first column of colors, right? So let us just fill it. So what can I say? I can say that DP of 0, 0 is equals to R0. DP of 0, 1 is equals to G of 0. G of 0. And then DP of 0, 2 is B of 0. B of 0. Right? So if I just return the minimum of DP of 0 and R0, DP of 0, 0, 0, 1, 0, 2, that means for n equals to 1, I'm getting the answer. Right? Right. So step 3, I need to compare for the rest of the things. So what can I say? That I need to run the for loop for I equals to 1, I equals to 1. Let me write it correctly. For I equals to 1 to I less than n, I plus plus, right? And then what I need to do is to start comparing it. So I am at this ith row and I'm filling the first cell. Similarly, I will be at the ith row and I will be filling the second cell and the third cell every time. So let me just copy it. Copy it. Right? So filling the first cell. So take the first color from R of I and take the minimum of the remaining colors. Take the minimum cost of the remaining colors because no two adjacent colors can be colored with the same paint the adjacent houses, right? So math dot minimum, it should be, I'm taking the values from the above row. Since I'm filling the first cell, then I will take the help of the rest of the colors, that points to 1 and dp of I minus 1 and 2. Yeah, great. I'm filling 0, then I will take help from 1 and 2. If I'm filling 1, I'll take from help from 0 to 2. So let me write that thing. So let me copy paste it and then we will make the necessary changes. So it will be g of I, and since I'm filling the first, the second cell, which is 0 based indexing starting to 1, then I will take the help of the first cell as well as the last cell, right? And now I'm filling this the third cell, which is pointing to blue color. So I will take the blue color as well as the, from the above row I will take the possibility, I will take the answer from 0 and 1 because I am filling the third cell. So that's it, and we discussed that at last we just need to return the minimum of the all the cells we have. For n equals to 3 we want, so we need to return the minimum of the third column cells. So I will just write math dot minimum dp of what, dp of n minus 1 comma 0, dp of n minus 1 comma 1, and I have to compare it with the dp of third point is n minus 1, third cell is actually 2, and I need to mention this inside the min function. I will say math dot min. I hope this logic is very clear to you. So let's compile and run and let's see for ourselves what is the time complexity that we are using here. Okay, so let me just get me free of this syntactical errors. So since we are making 2D array, I need two big brackets, but long found. Okay, okay. I think it will work now. Let's see. Okay, okay. What's the problem? Log cannot be dereferenced. Let me see. Okay, so there was the problem of I made a mistake and I'm mentioned the full stop there. So let's compile and run it again. Okay, so your output and expected output matches. So we will custom run it for the second test case and we will see that if it is running good or not. It was 2, 1 and 3. Then it was 3, 2 and 1, right? And the last was 1, 3, 2. So let's compile and run again. So great, our output and expected output matches. So let's just hit the submit button now. And since our code is just making a DP array, so that will be O of n complexity, that is space complexity of O of n cross 3. And we are just using a for loop, and these operations are O of 1. So the time complexity will be O of n, and that will be definitely is 10 power 4. So that will be definitely less than 10 power 5. So that's it for today's video. And if you like my content, and please subscribe our channel so that we can make the new video with the tomorrow's streak. And few last thing that this is my DSA repository. You can start on fork to get help with the source code, as well as this is my Instagram channel. You can connect me here as well as on LinkedIn for any doubts and guidance you may have. And let's see tomorrow. We'll meet tomorrow. Till then, bye bye. Take care. Keep solving and just keep going.